And I want to show you how to solve this equation involving finding the maximum dimensions for a cylinder enclosed in a cone. What that give you is this triangle, this cone. And the best way to do it is to draw a diagram. It'll help you out to see that if you cut the cone in half and represent it as a triangle here, and you look at the cylinder inside it, you see that you can find two similar triangles. And you can take that ratio with finding the height and width of the triangle, 805, and the ratio for similar triangles, and you take the height and width of the triangle from the cylinder, which would be h over 5 minus r, whereas r is the radius of the cylinder, and you just solve for h, which is the height of the cylinder. You solve for h, and then you can come up here and you can take the equation for the volume of the cylinder, and by finding the derivative and finding the setting that to zero, and finding the derivative and setting it to zero, you can solve for r. And you're going to end up getting r equals two values, r equals 0 and 10 over 3. But r cannot equal 0 because the radius can't equal 0, so you're going to take this value, 10 over 3. And when you do that, all you have to do is plug it back in to your equation for height. In order to find the height, we'll give you 8 over 3. And it's important to remember why we take the derivative. We're taking the derivative to find where the, the function goes from increasing to decreasing right here, which is why we're getting the maximum value out of this equation.